Welcome to this video. I will talk about T-factor, triangular factor. I will give some definition and we'll check some properties. We just consider a generic triangle with sides having lengths A, B and C. Also, we assume that A is bigger than 0 and smaller or equal B, and B smaller or equal C. With this definition, every triangle can be taken in consideration for triangular factor. Definition, again, A bigger than 0, smaller equal B, B smaller equal C, and we have a definition of three factors, TF1, TF2, TF3. Each T factor is function of two sides. So TF1 is a function of A and B, and is the sum of square of A plus the square of B, and both divided by AB, product AB. TF2, a function is A and C, is same way. It's the sum of square of A plus the square of C, and all divided by AC. And TF3, function of BC, is the sum of square of B plus the square of C divided by product BC. The triangular factor is a dimensionless number because it's the division between two areas. So a square, the square of A plus the square of B is an area. The product of AB is also an area. So the resulting value has no dimensional unit. A triangular factor is always bigger or equal to. Proof, we consider at the moment just TF1, function of AB. I took the formula and I added two monomials, 2AB and minus 2AB. The total of this operation is 0. So adding these two monomials doesn't change the content, the result of operation. But I can exchange B squared with 2AB and put in evidence the first three monomial here, squared 2AB minus 2AB plus B squared. If I continue, I can show, I can see that the first part is the square of A minus B, the first three monomials, plus 2AB, the green one, divided by AB. And we can next split into fraction, A minus B squared divided AB, plus 2AB divided AB. So the result is the first fraction plus 2, because the second fraction is simply simplified with number 2. So if A equal B, the first fraction is 0. This fraction is 0. So we have TF1 is exactly 2. If A not equal B, then the first fraction is bigger than 0, and TF1 is exactly bigger than 2. Also consider that being the t factor bigger equal to, we can write this equation, or this inequality is the result of previous proof, and we have square of a plus square of b bigger equal to ab. We can simply add 2ab to both sides of inequality. We are talking and dealing only with positive numbers, so we can we have that the first part of inequality is the square of a plus b, and the result is a plus b, square of a plus b bigger or equal 4ab, the sum of 2ab plus 2ab. And we have doing it square root of both sides and considering only the positive result, we have a plus b bigger equal 2 multiplied square root of a multiplied b, and this can be expressed simply in this way: a plus b divided by 2 bigger equal square root of ab. This result is already presented in some videos in the on internet, videos that show how to get this result using a geometric approach. In this way we see that it's possible to get the same result also by algebraic approach using the property of triangular factor. We have a same property for TF2, TF3. We can have make the same proof, and we have TF2 bigger equal than 2, TF3 bigger equal than 2. And if we define triangular factor ABC as a sum of TF1, TF2 and TF3, then any triangle has triangular factor, global triangular factor bigger equal than 6. And only equilateral triangle has TF equals 6. Okay, this is the first part of videos regarding a triangular factor. Next video we will see properties regarding right triangle. Thank you for watching the video and see you next time.